Hello everyone and welcome back. So now we're going to jump into example 9-20. Now, oh man, every time. 9-20. So your book actually has gotten this problem wrong. So do not follow the example that's in your book. They have made a mistake. And just follow mine. So what's happening in this one is we have a steel bar having a cross-sectional area of 1 inch squared, and suspended vertically and subjected to loads as shown. So the bar looks something like this. We have a bar, it's connected to the ceiling. Before you're worried, don't worry, it doesn't tell us to worry about the weight. But it gives us some dimensions. And so what we have here is we have a few loads. We have a 6,000 pound load right here. 6,000 pounds. We have a 4,000 pound load right here. 4,000 pounds. And we have a 3,000 pound load right here. 3,000 pounds. So this is 4 feet down, and then this is 2 feet further, and then this is 1 foot, goodness. Now, it's asking us to find the total elongation of the bar. And it says that E is equal to 30 million psi. Which makes sense for steel. Okay, area is equal to 1 inch squared, and the length of the bar was equal to 7 feet, which I want to go ahead and translate that to inches, which would be 84 inches. So, the total elongation will be the elongation due to all three of these things, each with their own length. So, delta total, it's going to be equal to delta 1 plus delta 2 plus delta 3. Each of these little sections is seeing their own length and their own stresses, their own weights. Oh, and your book did do it right. They just did it in a different order than I was expecting. Sorry. Now I can see what they did. Okay. Your book is not wrong. They just did it in a very different direction than I thought so. So we'll do the elongation due to this one, and then this one, and then this one. So we'll call this guy delta 1. And that's equal to 6,000 pounds. And we have the length, which is going to be 84 inches, because that's the full length for this guy, over 30 million, times the area, which is 1 inch squared. And that's going to be equal to 0.024 inches. Okay. Now I'm going to look at this guy, delta 2. Now you got to think about that. Delta 2 is going to feel 6,000 pounds and the 4,000 pounds. So it's going to feel 10,000 pounds total. It's also going to be, make sure I'm doing everything right. I usually am not. I know I made a mistake. Sorry. That was my length for this problem right here. This should have been 12 inches. My bad. It's only the length until I reach another force. So delta 2 is going to be feeling both of those forces. It feels 10,000 pounds. And it feels a 2 foot length because that's how the distance until the next force. So 24 inches. All over 30 million times 1 inch squared. That's going to be equal to 0.0080 inches. And finally, delta 3 will feel all of the weight, because it's got everything underneath it, 13,000 pounds, and it's got a distance of 48 inches, all over the same modulus, it's in the same area. And that comes out to be 0.0208 inches. Okay. Oop, that doesn't look very nice. Let's erase this right here. My marker's not working as nice as I want it to. And then so our total elongation is equal to 0.0024 inches. There's supposed to be a second 0 up here. Plus 0.0080 inches. Plus 0.0208 inches. And it comes out to be 0.0312 inches total. That is our total elongation due to the three forces. Well, I hope this made sense. If you have any questions, please feel free to contact me. I'll see you next time.